Let's see problem 14.7. Okay, here we have a 3 kilogram block is released from rest at A and slides down the smooth parabolic surface. Determine the maximum compression of the spring. So in this problem, you are dealing with two types of sources of energy, which is potential energy, okay, due to height, and also spring energy due to spring here. So let's do a little bit of drawing and see what we are going to have. In this problem, you have the slope, and then you have spring at the end of the slope. Okay, so you have spring here, and then this is the object, okay, and then this is the height, which is 1 meter, and then this is the horizontal distance, which is 1 meter. And then this is the equation that defines the movement, y equals to x squared. But in this problem, it says that it's a smooth parabolic surface, so no normal force acting on this object. So remember that what is the equation for spring? So equation for spring, u from 1 to 2 equals to minus half k s 2 squared minus 1 on half k s 1 squared. Okay, so this is the equation for spring, for the spring energy, and this is the equation from 1 to 2 for the potential energy. Okay, this is minus weight times delta y. So we are moving downwards, right? So for the spring, before we go to the spring, we write the kinetic energy and the total energy. So we have T1 plus sigma of all energy, which is the summation of kinetic and the potential and the spring energy, 1 to 2 equals to T2. So we have some clues here. First one is, it says that the block is released from rest, so which means that T1 equals to 0 and slides down the smooth parabolic surface, determine the maximum compression of the spring, and then it rests, so which means that T2 is also equals to 0. So we are left here with potential energy and also the spring energy. Now let's see what we can do here. Sigma u is the summation of spring energy and the potential energy. So the first distance for spring is also equals to 0. Okay, the first is 0. So we are going to be left with this for the spring, and also this is for the potential energy. Let's write here. So here T is equal to 0 plus the spring energy, okay, so minus 1 over 2 ks squared, okay, ks squared, okay, plus this is the potential energy, okay, minus w delta y equals to 0. So we know y is equals to 1. However, when we talk about 1, we are moving downwards. So here, this is going to be minus 1. And this is w equals to 3 kilos times 9.81. Okay, and then we have this k value equals to 1000. So we are left with trying to find s. So at the end of the day, what you're going to have is half times 1000, and then s squared, okay, So this is minus and this is plus. So negative and negative here will give you positive. So you have 3, 9.81, and this is 1 equals to 0. So we try to solve for S over here, and then you're going to get the spring compression equals to 0.243 meters.